Shut up, Albert. Hi everyone, today we're going to talk about area between curves and volumes of revolution. I'm Melanie.
I'm Irene.
And I'm Terry.
We're AAHL, and we generated these images with AI, so just a disclaimer. But this was our original work. So number one, volumes of revolution.
So basically, volumes of revolution is you must start with a function, and then you can rotate it around the y or x axis and get a solid, and then this solid is your revolution, and you're trying to find the volume of this revolution. So the formula you would use would be these, and you can see that on the left you have the one where you rotate around the x-axis and you're using the integral of the function in terms of x, and then it is bound by where it is on the x-axis, as you can see by the little a and b, and it's the same for the y-axis except you're doing it in terms of y. So yeah, that's the formula. And then here's an example. You can do this. You can pause this video and give it a try. You can use the formula as a hint. Okay, so here's the solution that I wrote. So you can see how I wrote it so that you can rearrange it to be in terms of y, as it's a revolution around the y-axis. And you can see how I proved it to be pi over 12. Wait, I'll move.
Is this area between two curves?
You didn't click it.
Oops.
So we will be looking at two cases. The first case in this section, we are going to look at finding the area between two curves. There are actually two cases, and we will be looking at both of them. So in the first case, as you can see in the image, we want to determine the area between y equals fx and y equals gx on the interval a, b. We are going to assume that fx is the curve on top, which is larger than the gx, and we will be looking at the sketch to get an idea of how the area should look like.
Yeah, so we can also use this formula to determine the area of the curve. So as you can see from before, this would be fx and this is gx. And you can find this area between using this formula.
The formula is basically telling you to subtract the integral of the bottom from the integral of the curve on top, as illustrated by the formula written here, and the bottom is basically an illustration of what the formula actually means.
Yes. Okay, so case 2. Let's move on to case 2.
The second case is almost identical to the first case. However, we will determine the area between x equals fy and x equals gy, as illustrated on the image here.
Yes, as you can see here, green represents the area, and we are trying to find that right now. So what we have to do is basically apply our previous formula given.
However, we will be changing fx and gx to match fy and gy.
Yeah, so you need to find the inverse first because the axis is different.
And what the formula basically means is the integral of the right-hand side function, which in this case is fy, subtract the left-hand side function, which in this case is gy.
And it's all in terms of y, just like the volumes of revolution when you did it across the y-axis. So that's very, very, very important to note.
Yeah, so that would be how you calculate this area between x equals fy and x equals gy. So please use this formula whenever you need to conduct this mathematical
And
equation.
remember, every time you integrate the function, you have to sub in your according coordinates, which is C and D in this scenario.
It's like where it's bound on each respective axis.
So our time is running low now, so we will conclude today's lesson with Mr. Patrick saying thank you for listening. This one we didn't generate with AI. This was very, very carefully crafted by us. So if you look really far, there's like an illusion, like an optical illusion. Where
Drag the laptop out.
like drag the laptop out, and it looks the exact same as him. Okay, thank you.
Thank you.
Thank you.
Bye. See you
Bye.
next time.